right, 9.4, you guys should have it pulled up. Parametric equations. All right, I'm going to introduce you to some new vocabulary. We're going to look at some things a little differently. But the algebra behind this is nothing that you guys haven't seen before. All right, up to this point, we have talked about everything with two variables that we've graphed, x and y, right? We're now going to introduce a third variable to represent a curve in a plane. All right, we're going to represent a curve in a plane. A lot of times this is used, parametrics are used following the flight of something. All right, you guys have seen these types of equations before, just probably not ever needed to solve them or evaluate them. This is called a rectangular equation. A rectangular equation, guys, look, it has an x and a y. We're going to take rectangular equations and we're going to change them into parametric. And then we're going to change parametric into rectangular. A parametric equation is going to have x's, y's, and what else? T's, right? Parametric equations show things, they graph things in respect to time. It's going to make some sort of a curve in a graph. It's not a circle. It's not a sine curve or anything like that. It shows the pattern of flight, generally, of something, movement. So it's going to have a direction to it, okay? Everybody with me? Okay, so here's some vocabulary that you guys may not have heard, may have heard some of you. But what a parametric equation does is it tells the whole story of something. Right now we know where an object has been, but you don't know exactly where it's going. And I know some of you are like, I don't care where it's going. That's okay. That's fine. But we are going to determine, we're going to introduce the t variable. It's called the parameter. And then you're going to write the set of parametric equations that can show you where an object has been and where it is going. And we'll be able to graph that path. Okay, so we're not doing anything yet. I'm just showing you what these are going to look like. So you're going to have equations that have x's and y's in them and also what? T's. Because this is just, you're talking about equations with respect to time. All right, just a little example here. It's going to give you a resulting path in a plane curve. Plane, not like an airplane, but as a coordinate plane that we're talking about. Okay, so here we go. Let's look at this. Graphs of plane curves. We're going to graph these. We're going to solve them and we're going to graph them. If you have a calculator, get it out. You're allowed to use scientifics. Scientific calculators are fine. Now, what is very important, guys? One very important thing is we're going to plot points, right? We're going to plot points on our XY plane. You guys are very familiar with plotting points. X goes left and right, Y goes up and down. The value chosen for the parameter is t. You're going to be given t values. You'll see this in a second. And we're going to evaluate at a specific t value. This is going to give you the specific direction. It's called the orientation of your curve. This will all make sense in a second. It is very important. You'll see on WebAssign, and it's going to be very important on your quiz, that you draw these little arrows. That's the crux of this parametric equations, is that it's showing you specific direction that an object is going, the path that it's moving. That's what we're doing. We're going to plot this path over time, okay? So here's two equations. This is what the directions would look like. Sketch the curve given by the parametric equations. Describe the orientation of the graph. What this means, you're going to plot the points that you get, but you're also going to describe the orientation, meaning you're going to draw little tiny arrows on your curve. Now, they have given us our t values. Where are the t values that they gave us? They told us what to use, how to evaluate. Anybody see them? Where are the t values that they want us to use? -2 to what? +3. Does it include -2 and +3? Yes, so when you plot your points, what should be at -2 and at +3? Closed circles or open circles? Closed. Okay, good. So this is how I want you guys to do this. We're going to represent, we're going to graph this. We're going to make a big chart. It's kind of like a T-chart, but it's got more info on it. So here's your time. This is the time values that we're going to use. Here's my X, here's my Y, and then I want you to actually write out the point. So we're just going to evaluate, excuse me, both equations. We're going to evaluate the X equation, we're going to evaluate the Y equation at each time interval that they gave us. So we're going to evaluate at -2, at -1, 0, 1, 2, and 3. Does that make sense so far? I'm going to evaluate, excuse me, in the X equation first. So I'm going to take this X equation right here, and I'm going to plug in -2. So I have -2 squared minus 4. What is -2 squared? 4. And then 4 minus 4 equals 0. So my point at time -2 is 0, comma. How do I figure out what the Y is? Plug it into the Y equation. So I'm going to take -2 over 2 and get what? -1. So the first point that I'm going to plot is 0, -1. Questions? Okay, so we're going to do it again. Now I'm going to evaluate where time is -1. So I'm going to take -1, say -1 squared minus 4. Well, what's -1 squared? 1, and 1 minus 4 is? -3, perfect. So the X value at that is -3. Now I'm going to find the Y. So I'm going to take this Y equation, and I'm going to plug in -1 for the T. So I have -1 what? -1/2. You guys with me? All right, so now we're going to evaluate at 0. So I have 0 squared minus 4. Well, what's 0 squared? -4. So my X value, where time is 0, is -4. And then I'm going to plug into the Y equation. So I have 0 over 2, which gives me what? 0. Perfect. So now we're going to evaluate with 1. So I have 1 squared minus 4 equals what? -3. Good. Now I'm going to evaluate for Y. I'm going to put in +1. So 1 over 2 is just 1/2. Good. Now I'm going to evaluate with 2. Correct. 2 squared minus 4. So 4 minus 4 is 0. And then I'm going to plug in +2. So 2 over 2 is +1. Good. Now we're going to evaluate with 3. 3 squared minus 4. 3 squared is 9. And 9 minus 4 is, so my point is 5, comma, 3 over 2. Okay. Does anyone have any questions about where in the world I got those numbers? Why did I use the numbers -2 to +3? Because that's where they told us the T values to use. They gave me the two equations. So at that specific time, I was figuring out what my X value is and what my Y value is. Yeah.
So let's say it's like instead of like less than or equal to 3, what if it says more or equal to 3?
It'll give you a specific, they're not going to make you do it like 1,000 times. All right, so now we're going to graph, and we're going to plot our points. This is very important, guys, that you understand how to plot the points. You want to plot the points, and you want to connect them in the order of time that was given. So what point should we start with? 0, -1, because that's the lowest value we had for T, right? So you're going to start with -2, that point, whatever that point is at that time, and then with the 1 at 3. So watch. I have a point at 0, -1. You guys agree right there? Then my next point is at where? -3, -1/2. So I go net left 3 and then down a little half-ish. Then I have a point at -4, 0. Then I have a point at -3, +1/2. Then I'm where? At 0, 1. And then I'm at 5. 1, 2, 3, 4, 5. And then 1.5-ish, right? You guys agree? So from point to point, from our lowest time value to our highest time value, we are going to graph this. So watch, we're going to graph And the direction is extremely important. So along your little graph, you need to give me some arrows to show me the direction that this flight path of whatever object that we're talking about is going. Yes, Jean. Oh, just stretching. If you had a multiple choice question and they had arrows going this way, same points and everything, but the arrows are going in the other direction, that is wrong. Correct. So it's important that you guys understand what this is representing. You're finding where an object is in a specific point in time. Yes.
So the arrows are always going to go that way?
No, it's always going to go from start. See, I started my plotting here at your lowest time value, and then it always goes to the highest. You always go in increasing time.
Oh, okay.
Yeah, in order. Yeah, you can say it like that. All right, let's do another one. This looks weird. It feels weird, but it's not necessarily anything that's just crazy hard. All right, so we're going to do the same thing. We're going to evaluate. I'm going to have some time values. I'm going to find out what x is at that point in time. I'm going to find out what y is at that point in time, and I'm going to find my ordered pair. What values am I using now? -1 to where? To 3/2. All right, -1 to 3/2. Now, I noticed that 3/2 is not a whole number, right? So you guys might be thinking, well, where do I go? From -1, then do I go to -1? You can just go to all whole numbers and stop at 3/2. Meaning, I'm going to start at -1. What's the next whole number? 0. And then I'm going to go to 1. And then I'm going to go to 3/2. So we're going to evaluate each equation. I'm going to evaluate first for x, then I'm going to evaluate for y. So for the x, I have 4 times -1 squared minus 4. Just be careful with signs and stuff, guys. What is -1 squared? 1 times 4 is 4, and then 4 minus 4 is perfect, 0. Now I'm going to plug in -1 for t. Well, what does that equal? -1. Good. Okay, so now we're going to plug in 0. So 4 times 0 squared minus 4. What's 0 squared? 0. Times 4 is 0. Minus 4 is? No, it's -4. And then I'm going to plug in 0 for t, which just gives me what number? 0. Perfect. So now 1. 4 times 1 squared minus 4. What's 1 squared? Times 4 minus 4? 0. And then when I plug in, I get 1. Good. Now 3/2. All right. This may be a little harder, but I think you guys can handle it. I have 4 times 3/2 squared minus 4. What do I do first? I square. So I have 4 times what? 9/16. Good. Can I simplify anything? 9/4. I don't know why I said that. Thank you. Sorry. Can I simplify something?
Yes.
As soon as I said that, I'm like, that's not what I meant to write. So my 4's cancel, right?
Oh, yeah.
Agreed? What's 9 minus 4 now? 5. And then I'm going to plug in 3/2 to my y equation. So what does that just give me? 3/2, 3/2. So there, we just evaluated. All you guys are really doing is just evaluating 2 equations. And now if I graph it, the direction is extremely important. So 1, 2, 3, 4, 5. Where is my first point? At 0, -1. Okay. Where is my second point? -4, 0. 1, 2, 3. -4, 0. Where's my next point? 0, 1. And then where's my last point? 2, 3, 4, 5. And here-ish. Now, what is important here? How do we connect the dots?
Is the equation always going to have that shape?
A lot of times. But what? Where do I start?
In the bottom one.
At the bottom. I start at the smallest time value, which was -1, and I go to the highest one. And then what is important? What has to be included in this? The arrows. You have to show me the direction, the orientation. You got to show me how this is moving. Questions? All right, so if you're given a question and it just says, sketch the curve of the parametric equations, that is what is being asked of you. You'll be given the t values to use. You plug them into whichever equation, x into x, y into y, and then graph it. Make sure that you have your arrows. We okay with that part?
Yes.
Yeah.
Okay. All right, now we're going to talk about eliminating the parameter. Okay, this is just some algebra stuff. It says many curves are represented by a set of parametric equations. Their graph is also represented as rectangular, which just means, what does a rectangular equation have? It only has 2 letters. What are they? X and Y. Okay, a parametric has 3. It's got X's and Y's and T's. So we're going to find the rectangular equation. We're just going to find the equation that just has just the X's and the Y's in it. And the way that we do that is called eliminating the parameter. That's what we're about to do. Because remember, the parameter is t. The t value is called your parameter. So we're going to do something called eliminating the parameter. What you guys are going to be doing, you're going to solve one equation for one letter and then use substitution. So look, here are the 2 equations that you're given, right? You guys see your 2 equations?
Yeah.
All right. So in order to go from one to another, we have to solve one for the other. Everybody with me? How did I get from first step to second step? What did they do?
They divided the 1/2.
Okay, they divided the 1/2, right? Multiply both sides by 2. Do you see how they took this equation right here? Everybody see? And they solved for what letter?
For Y.
Well, it's already solved for Y, so they solved it for what? They solved it for T. They got here. Then what did they do? They took that equation and they plugged it in. Because what are we trying to do? We are trying to eliminate the T. So what they did, they took this, look, and they put it in right there to eliminate. You're going to solve one equation for T, then plug it into the other one. You are eliminating the T values, the parameter. Yep, that's it. That's all you're doing. That's it, that's it, that's it. All right, so let's look at this. You have something like this. All right, the first thing to do, guys, is pick. Pick which equation you think is going to be easier to solve for T. Which one do you think would be easier to solve for T?
Right.
Why the one on the right? Because there's no square root, okay. I think the one on the left would be easier.
Yeah, you just square root. Oh, no.
Why is the one on the left easier? How many T's do you see?
Oh,
Just one, right? The one on the right has 2 of them.
weird.
Let's work on this one. Let's solve for, that's okay. That's why I don't like using T's, right? If it was an X, you guys could see it better, but we can't use X's in this case. So if I'm going to solve for T, all right, let's solve for T. You guys are like, I don't even know where to start. Well, could I put this over 1? Can I do that?
Yeah.
Sure. If you have a fraction equal to a fraction, what can you do? We can cross multiply, okay? We're just using algebra skills, guys. So I'm going to rewrite this. I'm going to say x times the square root of t plus 1. If at any time you believe that my t turned into a plus sign, just, give me a little shout, please. Everybody with me? Okay, we're trying to get t by itself. Trying to get good old t by itself. So now what do I do? Which I divide both sides by. Good. Divide both sides by x. Good. So I have the square root of t plus 1 equals 1 over x. Agreed? Okay. We're still trying to get t by itself. Use your algebra skills. What am I going to do to both sides? I'm going to square both sides. Good. What you do to one side, you do where? To the other. So what? Square the square root goes away. So I have t plus 1 equals 1 over x squared. Yeah? Everybody with me? All right, what's the last thing I do? I'm gonna subtract 1. All right, now is this the most beautiful thing in the world? No. But I end up having t equals 1 over x squared minus the whole number 1. Everybody agree with me? So now that I've taken one equation and I've solved for t, we've done this a million times. We've done this with compositions, combinations. We've done this with elimination, substitution, variables and stuff like that. You solve for one to plug into the other. So I'm going to take this and I'm going to put it in over here everywhere I see what? A t. All right. Now, again, this is going to test your algebra skills a little bit. But we can all handle this, I promise. So I have y equals, instead of t, I'm going to write 1 over x squared minus 1, correct? Over what? 1 over x squared minus 1 plus 1. Right? You guys are like, oh, okay, relax. Does anyone see anything that could make life a little easier? Minus 1 plus 1, what do? They cancel out, okay? All right, not bad.
Would it be easier if you solve the 1 over x squared minus 1?
Let me just finish.
Can you multiply?
Can you just multiply what? So you keep change. Okay, can we keep change flip? You keep the numerator, right? 1 over x squared minus 1. What do I change my multiplication to? What do I change division to? That's what I meant to say. Multiplication. And then what happens?
It's x squared on top.
Then it becomes what? When I flip it, what does it become? Tell me. X squared what? Over 1.
Distribute the x squared. 0. They cancel out.
Did you just say 0?
Wait,
This way, look.
1 minus 3.
Hold on, let's look at it this way. That's good that you're thinking that. Well, look, do you guys agree this is together, correct? Yeah. Why is that together? Because there's that minus 1 there, right? Whenever anything's attached with a plus or minus. So what could I do? What's happening algebraically? You said it before. What's happening with that x squared on the outside? Can I distribute it? Yes? Okay, so when I distribute this, this becomes x squared over x squared, right? Minus x squared. Everybody agree with me? Okay, now you guys are like, wow, there's so many x squareds, guys. Algebra. Think algebraically. What is x squared divided by x squared?
1.
This is 1 minus x squared. So y equals 1 minus x squared. Yes, Jean, that is what you said. Now, as soon as we see fractions and square roots and all that good stuff, we're like, oh, no, I just can't do it. It's too hard. You guys are going to have to rely on your algebra skills. You're going to have to rely on your algebra skills. We are going to practice this more, I promise. I gave you guys a web assign. I have one more I want to do, but I'm not going to get to it, so I'll just record it. But I gave you a web assign. I want you to try and do it. I'm going to go over the web assign questions in class on Monday. Tomorrow, if you have questions, underclassmen, when you're here, ask me. I will do them. I will work them out. I'll probably make a video this weekend of them. But please watch the video that I posted. It's in modules. It's a good introduction to this stuff because it's not anything you guys can't handle. It's just super different.